Hello students, my name is Shweta Singh. Today I am going to deal with the lesson the Raman effect, the very first lesson from English for engineers. Yeah. From the lesson, we could guess about who this lesson is going to be. Obviously, it's none other than Dr. C.V. Raman, one of the India's greatest scientists, who won a Nobel Prize. The lesson is also introduced as such. In the year 1930, the most unexpected thing happened in the world of science. Okay, a young Indian researcher, Chandrasekhar Venkatraman, won the Nobel Prize for Physics for his groundbreaking discovery of the phenomenon called the Raman effect. So, this is the introduction of the lesson. We obviously know that this was one of the greatest honors for India. Even before we learn what the Raman effect is, we'll look at Chandrasekhar Venkatraman's early life. Sir Chandrasekhar Venkatraman was born on November 7, 1888. He was one of the India's physicists, mainly known for his work in the field of light scattering. He was born to a simple pair, Tamil parents, R. Chandrasekhar Iyer and Parvati Ambu. His father was a physics teacher, so it cannot be a coincidence that uh, his Chandrasekhar Iyer's youngest son developed interest in physics and which became a passion for his life. We understand Raman was a precocious child because he completed his secondary and higher secondary education at the age of 11 and 13 respectively. That was too young age to finish the higher secondary education. And not only this, he also topped his bachelor's degree examination at the University of Madras with honors in physics from Presidency College. And he achieved his bachelor's degree at the age of 16. That was also a too young age to finish off one's bachelor's degree. And during his study at the Presidency College, he published his first research paper on diffraction of light in the year 1906. During this time, he was still a graduate student, and the very next year, he obtained an MA degree, and he was just 19 years of age when he joined the Indian Finance Service in Calcutta as an assistant accountant general. Here we say actually the deputy accountant general. So during his study of MA for 2 years, he hardly attended his classes. He developed self-learning during these 2 years. He kept on experimenting, and that's how he could publish his first research paper on diffraction of light. And it's very difficult to crack a civil services examination at the age of 19 years when you're still studying. But this person, he was so intelligent that he cracked his civil services examination and got his first job in Indian Finance Service in Calcutta as a deputy accountant general. He was posted in Calcutta. There he happened to get acquainted with ISCS, that is Indian Association for the Cultivation of Science, the first research institute in India. So we can understand his interest in physics because in spite of being in such a highest position in the job, he after his working hours he could still find time to pursue research work at the ISCS. During this time, he actually made major contributions in acoustics and optics. So optics is a branch of physics that studies the behavior and properties of light. And in 1970, he finally gave up his administrative position to become a professor of physics at Calcutta University. So, uh, merely for the interest of physics and passion for physics made him resign from his highest paid job and pursue his dream of become teaching physics. And he became a professor of physics at Calcutta University. It so happened that in the year 1921, he was invited to attend the delegates as a delegate at the Congress of Universities of the British Empire at Oxford. So it was his first trip overseas, and this Congress was hosted by none other than J.J. Thomas and Lord Rutherford, the leading physicist during Raman's time. These two were very well acquainted with Raman's significant study on acoustics and optics. As we already studied what optics is, let us see what acoustics is. Acoustics is a branch of physics that deals with the study of mechanical waves in gases, liquids, and solids, including topics such as vibration, sound, ultrasound, and infrasound. Raman had studied classical percussion instruments like tabla and mridangam more specifically the mathematical relationships that produce the pleasing effects of the sounds. So this was one of the uh, interesting fields. He studied the acoustics of various violin and related instruments, including Indian stringed instruments and water splashes. Not only this, he even performed experiments with mechanically played violins. So this was his study about acoustics and optics. But let's get back to his voyage to England. Okay. During his voyage to England, he was awestruck by the blue color of the sea. So he was on board the the SS Narkunda. This is the name of the ship on which he traveled to England in the year 1921. So during this time, he was so much awestruck by the blue color of the Mediterranean Sea that few things speculated in his mind. So till then, there was generally accepted theory about the blue color of the sea, that the blue color of the sea was the generally accepted theory was that the blue color of the sea was merely the reflection of the sky, and this was confirmed by the celebrated physicist Lord Rayleigh, who had proposed that the minute particles in the air scattered the blue wavelength from the sun's white rays. This is how he tried to explain why the sea color is blue. What he said is that the minute particles in the air scattered the blue wavelength from the sun's white rays. That is the reason the color of the sea is blue. This was a theory which was accepted by the people till Raman gave his theory. Raman was not convinced with this theory. It has stuck to his mind that the color of, he speculated actually, he guessed that the color of the sea is blue because of the scattering of the sunlight by the water molecules. So Raman speculated that the blue color of the sea is because of the scattering of the sunlight by the water molecules. In order to prove his speculations, he used Nicol prism on the sea water, okay, where he could, uh, on a sample of seawater, to show that light was indeed scattered by the water molecules. This phenomenon is called molecular diffraction. So as we see here, of several hypotheses on the color of the sea, the best explanation had been that, see, we understand that There were many more hypotheses related to the blue color of the sea, but mostly accepted theory was of Lord Rayleigh, who said that the much admired dark blue of the deep sea has nothing to do with the color of water, but is simply the blue of the sky seen by the reflection. But Raman proved him wrong, and he came up with the proof of his speculations of the blue color of the sea. His speculations were that the blue color of the sea was due to the scattering of sunlight by the water molecules. And he proved his speculations right by using Nicole prism sample of water. He gave this phenomenon a name called molecular diffraction. So the Nicole prism allowed Raman to view the water without the influence of sunlight reflected by the surface. So here we have an advantage of knowing the equipments, knowing various equipments and their usages. Here we are talking about Nicole prism, which has helped Raman to view the water without the influence of sunlight reflected by the surface. He described how the sea appears even blue than usual, contradicting Rayleigh. Okay. So Rayleigh said that the deep blue color of the sea is only the reflection of sky. But here Raman proved that the blue color of the sea is because of the scattering of sunlight by the water molecules, and also he proved that the sea, blue color is much more deeper than usual. So this laid foundation for his further research work. He did not stop at by proving that blue color of the sea is because of scattering of sunlight by water molecules. He further researched in this area, not only just one area that he researched, he has taken up three areas. One is scattering of light by liquids, the other one is scattering of X-rays by the liquids, and the third one was the viscosity of the liquids. Of these three, it was the work in the first area that fetched him the Nobel Prize. So, scattering of light by liquids. This was the area because of which he got his Nobel Prize. So, along with his associates, actually, he was working along with his associates on these three areas. So, over the next 7 years, he, along with his distinguished associates, conducted and supervised many experiments along these lines. So, Raman's second important discovery on the scattering of light was a new type of radiation, an eponymous phenomenon called Raman effect. So, we are talking about molecular diffraction first. In order to prove the scattering of light by the water molecules, in order to prove the blue color of the sea, uh, ultimately it led to Raman effect. In order to prove the blue color of the sea, Raman experimented with Nicole prism on the sample of water, where he could where he could prove that scattering of light was totally caused by water molecules. And this ultimately led to this scattering of light phenomenon ultimately led to Raman effect. After discovering the nature of light scattering that caused blue color of the water, he focused on the principle behind the phenomenon. His experiments in 1923 showed the possibility of other light rays formed in addition to incident ray when sunlight was filtered through a violet glass in certain liquids and solids. So he carried out a few other experiments where he could prove that the other light rays were formed in addition to incident ray when sunlight was filtered through a violet glass in certain liquids and solids. So this happened to so this was the phenomenon which led to the Raman effect. And they had the irrefutable proof of modified radiations observed in the scattering experiments due to molecular vibrations. The discovery was, and this discovery of Raman effect was announced through the Associated Press on 16 March 1928 with the following words by Raman himself. He said, I propose this evening to speak to you on a new kind of radiation or light emission from atoms and molecules. With these prophetic words, Professor C.V. Raman of Calcutta University began his lecture to the South Indian Science Association in Bangalore on 16 March 1928. So Raman proceeded to describe a discovery that resulted from a deceptively simple experiment conducted far from the great centers of scientific research in the Western world. What we understand from this discovery is that Raman, compared to what the West could afford, Raman did not have so many facilities for him to carry forward his research work. Yet, with his sheer determination and dedication, he could uh, come up with a groundbreaking phenomenon in competing in competence with in competence with the Western world, Western scientists, due to which he could win Nobel Prize. But Raman's Nobel Prize came 2 years later after his announcing the groundbreaking phenomenon. And he was the first non-white person to win a Nobel Prize in physics. Now, let us understand what essentially is Raman effect. Raman discovered that when a light beam travels through a medium, it is deflected by the molecules in the medium. Very interestingly, a small part of the emerging light beam, after being deflected by the molecules, had a different wavelength and a color from the phenomenon, which is initiated in the study called Raman spectroscopy. Now, this Raman spectroscopy finds a lot of applications in various areas, such as the molecular structure of compounds, handheld scanners for detecting drugs and explosives, the pharmaceutical industry, and medical diagnostics. Not only this, chemists can watch paint dry and understand what reactions are occurring as the paint hardens. Using a fiber optic probe, they can analyze nuclear waste from a safe distance. So this was one of the major achievements by one of the India's greatest scientists, for which we are all proud of. So thank you for joining me. Here we end our class. Thank you so much.